Hi there. In this video I'm going to show you how to determine how many atoms there are in a compound. So this is the very first skill you have to master in balancing equations. So if you look at this one, it's pretty easy. We've got one carbon, one hydrogen, and one oxygen. How about this one? Fe is the element iron. Hg is the element mercury, Mg is magnesium, so you have one iron, one mercury, one magnesium. Not too bad. Here we have some numbers as subscripts. This tells us that there are 12 carbons, so each number only goes with the immediately preceding element, the element that comes right before it. There are 22 hydrogens, and there are 11 oxygens. So notice, just to make the point clear, it's not 12 hydrogens and 22 oxygens. So it's not going this way. The numbers come after the element that they're modifying. 12 carbons, 22 hydrogens, 11 oxygens. This, by the way, happens to be glucose, a sugar molecule. So when you eat sugary candy, that's what tastes so good right there. Here we have one hydrogen and two oxygens. This would be the element hydrogen dioxide, would be the name of that. Here we have a parentheses. Now how do we do this? Well, the carbon's not too difficult. There's only one of those carbons. And then there's a hydrogen and an oxygen inside the parentheses with the 4 outside the parentheses. What does that mean? Well, just like in math, a number outside the parentheses is multiplying everything in the parentheses by 4 in this case. So there would be 4 hydrogens and 4 oxygens. So in this compound right here, there's one carbon, there's 4 hydrogens and 4 oxygens. How about this one? This is the same, except now there's a little 2 inside the parentheses. So just as before, this 4 multiplies everything, including that number, by itself. So again, there's only one carbon here, but now with the parentheses, there's 4 hydrogens, and 4 times 2 is 8 oxygens. So you're not adding these. It's not 4 plus 2 is 6. It's multiplying, just like in math. Multiplying in parentheses. 4 times 2 is 8 oxygens. Now we're getting a little trickier here. Here we have 5 carbons, and we have 4 times 3 is 12 hydrogens. 4 times 2 is 8 oxygens. How about this one? Here we have, now let me get my drawing tool right here. Okay, here we have a large number 2. Apart from this 2, just ignore this for a minute, we have 1 hydrogen and 1 chlorine. So that would be this. So the hydrogen is bonded with the chlorine, and it's a molecule right there. You call it hydrogen chloride, or the other name for it is hydrochloric acid. Okay, whoops. Now notice the big 2. What this means is there's 2 of these molecules right here. So this was the first hydrochloric acid, and there is a second hydrochloric acid molecule. So there's 2 of them, and that's where this big 2 comes from. Okay, now that's what it means. So what does it mean in terms of what we care about, which is counting the atoms? Well, any large number at the beginning of a compound or a molecule multiplies everything all the way to the end of the molecule by itself. Now this is pretty easy right here, but it'll require a little more thinking when there's little numbers down here in parentheses. We'll get to that in a minute. For now, it's pretty easy. There's 2 hydrogens and 2 chlorines. So 2 hydrogens and 2 chlorines. And if you think about what it means, that makes sense. Because here's a hydrogen and here's a hydrogen. Here's a chlorine and here's a chlorine. So 2 hydrogens and 2 chlorines, because there's 2 of these molecules. Let's go to the next one. All right, now this is a good one because we've got a big number and some small numbers. So first of all, without this big number, what's the actual compound? So you've got 2 hydrogens here. So I'll just draw this. You've got a hydrogen and another hydrogen, and then you've got 3 chlorines. 1 chlorine, 2 chlorines, 3 chlorines. Now this molecule may or may not exist in real life. This is just hypothetical for the sake of our example. So this large thing right here would be this made-up molecule. Okay, now the big 2, remember, is saying that there's 2 of those things. Chlorine, chlorine, chlorine. So there's 2 of them floating around. There you go. Okay, so that's what it means. What about in terms of counting the number of atoms? Okay, so since this guy, this large 2, multiplies everything by itself, this is going to be 2 times 2, which is 4 hydrogens, and 2 times 3, 6 chlorines. Remember, we are not adding here, and there's really no addition that goes on. It's all multiplication with these things. So 4 hydrogens and 6 chlorines. And again, going back to the nature of what this is actually telling us, this makes sense because we have, in these 2 molecules, we have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4, 5, 6 chlorines. But wait, it's about to get even more wild and crazy, because now, not only do we have a big number and a little number, but we have some parentheses here. How are we even going to think about that? Well, let's look at just what the compound itself is, first of all. So here we have 1 sodium, and we have this hydrogen chloride set, which is in parentheses, and it's multiplied by 3. So we've got a sodium. And what does this mean? This itself means that there are 3 of these chunks. So there's an HCl, hydrogen chloride, here, and there might be another hydrogen chloride over here, there might be another hydrogen chloride over here, and again, this is completely made up. This would not really exist in real life, but it's just for the sake of our example. Okay, that's the actual chemical thing that exists. This big 2 is saying, well, there's 2 of those guys. So here's the second one over here. HCl, HCl. Okay, so see how there's 2 of them? There's this guy, and there's this guy. 2 of these molecules, these made-up molecules. All right, that's what this means. What about in terms of how do we count it? Well, ordinarily, without this 2, there would be 1 sodium, but the 2 multiplies everything throughout the molecule by itself. So there are 2 sodiums. Ordinarily, before the big 2 comes along, there is 3 of these hydrogens. But since the big 2 is hitting it also, there's 2 times those 3, 6 hydrogens. Okay? Now, there would ordinarily be 3 chlorines, but since the big 2 hits everything throughout the molecule, there's 2 times 3, which is 6 chlorines. And again, going back to what this is really saying chemically, this makes sense. 1, 2 chlorines, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 chlorines. Okay? So it's really just a matter of multiplying everything all together. Alright, this is going to be the last one right here. This is the most complicated thing. You really won't have to do anything more complicated than this. So don't worry, it won't get any worse than this. Okay? Let's think about this. here, before you mess with the 3, let's figure out how many is in the actual chemical compound itself. There's 5 carbons. I'm going to go ahead and write out the initial thing. So carbons, we got 5. Hydrogens, what have we got? We started out with 3, but it's in parentheses being multiplied by 4. So we have 4 times the 3, just 12 hydrogens. What about the next one? Oxygens. Okay, we've got 2 oxygens, but it's multiplied by 4. 4 times 2 is 8 oxygens. Okay, so that's the base chemical, but we see there's 3 of those things. So everything gets multiplied by 3. So we say 5 times 3 equals 15. 12 times 3, because again, 3 of them, equals, let's see, that'd be 36. 8 times 3, 24. Alright, so 15 carbons, 36 hydrogens, 24 oxygens in this compound here. Alright, so I hope you followed along with that. It's not too bad. You won't ever see anything like this molecule right here. But if you're curious, I did do the math and figure out all the numbers here, so if you want a little extra credit challenge, you can try not to look at these answers and figure it out for yourself. But that's entirely up to you.